Okay, so now we're going to talk about another measure of center. This measure of center is called the standard deviation. So before we define the standard deviation, I just want to do a couple examples. So this problem says the length of five 2-inch carriage bolts produced by manufacturer A and manufacturer B are given below. What we're going to want to do is we're going to find the mean of these. Again, I could put these into the Excel spreadsheet, but the best thing to do is probably just add these up and then divide them by 5. So that's what we're going to do first, is we're going to add those up and divide by 5. So it's going to be 2.02, 2.01, 1.96, 2.00, and 2.01. And then we hit enter, and then we're going to divide that by the total number. We have 5 of those, right? So we are just trying to we're trying to find the average. The average is, in fact, 2 inches, right? Just so you know, a carriage bolt is just like a big bolt. You can Google it. It's used in like porches and things like that. So, all right. So now let's do manufacturer B. Let's average up the length of each of those carriage bolts. So 2.2, 2.7, 2.85, 2.1, and 2.15. And then we're going to divide that by the total, which we had 5 volts. So again, the average of this one is also 2. So you can see that these have the same mean, right? The problem is if we're making 2-inch carriage bolts, take a look down here. Some of these are way, way, way off, right? Like this would be way too small to be considered a 2-inch carriage bolt. Also, this one would be considered way too big, right? Whereas when you look at these are all continuous measurements, so you know we're going to never exactly be at 2 inches, but they're all pretty close. So who's doing a better job at making bolts? I would say manufacturer A. All right, the next one down here. Bank A has 3 tellers, and each teller has a customer line. Waiting time for 6 customers at Bank A is given here, and Bank B is given here. So what we want to do is we're going to find the average of these as well. So we're going to add all those numbers up, right, for Bank A, and then we're going to divide that by the total number of customers, which was 6. Whoops, sorry. I need to make sure we don't want to divide by 6 at the end here. We want to make sure we hit enter and then divide by 6. That's a pretty common error. So the mean wait time for somebody at the first bank was 5 minutes. Similarly, you can take a wild guess, but we're going to add up Bank B, 3 plus 5 plus 7 plus 4 plus 5 plus 6. Last time I checked, I think it is, in fact, 30. So when I add up the values here, we're going to get 30. We're going to divide that by 6 customers. The average wait time here is also 5 minutes. But when you take a look, I'm going to scroll down just a little bit here. It says, which bank is providing a more consistent experience? Well, take a look. You see up here, the range of this data set is 10, right? So you could be waiting 1 minute, you could be waiting 10 minutes. Whereas down here, these are all much more similar, right? It's 3, 4, 5, 6, 7. It's all pretty close. So which bank is providing a more consistent experience? Bank B. So what you're seeing in this example, up here with the bolts and then down here with the mean waiting time, is even though these data sets have a very different spread, their means are the same, right? So this is another example, just like in the previous video, where mean isn't working for us, right? Let's take a look. Which data is more spread out? We can see that in manufacturer B, this data is much more spread out, right? Data that is more spread out, we're going to say that that data set will have a larger standard deviation. When we take a look down here at these 2 banks, which banks is providing a more consistent experience? That's going to be Bank B down here, right? Because all these numbers are closer together. We would say Bank B would have a smaller standard deviation than Bank A. All right, so let's talk a little bit more about standard deviation. So standard deviation is the measure of spread. Another way we say this is, or how far on average the data lies from the mean. The larger the standard deviation, the more spread out the data. All right? This is a tough one. So I want you to take a second and think about this. If the standard deviation is 0, then what can we say about the data? If you want to think about this for a second, hit pause, but I'm going to give you a few. So if we have a standard deviation of 0, what that means, remember, standard deviation is the measure of spread, right? So if the standard deviation is 0, then there is no spread, right? So if the standard deviation is 0, then all the data values are the same. Okay, so let's talk more about symbols for standard deviation. Oh, I just want to make a side comment here. So here's a side question. Can the standard deviation be negative? Think about that for a second. Well, when we dig into this, the standard deviation of 0 is if all the values are the same, right? And then if the values start to deviate, the standard deviation will go up. So can the standard deviation be negative? No. The smallest it can be is 0. Okay, so symbol for standard deviation. So let's talk about that. The symbol for standard deviation of a sample, we're going to compare sample or population. You're going to see S or SX. The standard deviation for a sample, the formula for that, again, we're going to use Excel for this usually, but I'm going to write the formula out once. What we're going to do is I'm going to write this formula and then I'm going to explain what we're going to do. We're only going to do this once by hand, and then we will actually use our Excel spreadsheet to find this. So what you do is you take every X value, so in this case these are our X values, we're going to subtract them from the mean, then we're going to square that value, and then we're going to add all those numbers up, and then we're going to divide that by n minus 1, and then we're going to take the square root of the answer. So this is kind of long-winded and kind of heavy-handed, but we're going to do one of these by hand just so you can see how this works, and then I want to be very, very clear. After this example, we're going to be moving to Microsoft Excel to help compute these. So I'm going to stop this video right now, and then in the next video, shake your hand out, give yourself a little break, and then we're going to work on calculating the standard deviation of these 4 data points by hand.